Hello guys, welcome to Statistics Bio 7. I am Dr. Mohanathanari. We are discuss on the video interpretation of multiple linear regressions in OriginPro. So the how to analyze multiple linear regression in OriginPro, that video already published in our channel. That video link mentioned to this video description box. So the continue part of the video, interpretation of multiple linear regressions. So this is analyze the part. So the continue part for the interpretation and table making, graph explanation on this video. So go to the interpretation section. Multiple linear regression in OriginPro. Multiple linear regressions analysis is a vital statistical method for exploring the relationship between a dependent variable and multiple independent variables. It allows researchers to quantify the individual and collective impact of predictors on an outcome, making it a cornerstone in the fields like agriculture, bioeconomics, and environmental science. OriginPro engages this analysis by providing advanced tool for regression modeling, visualization, and residual diagnostics, ensuring comparative and reliable insights. In this study, employs the multiple linear regression analysis in OriginPro to investigate the effect of soil fertility, rainfall, and pesticide usages on crop yield through the statistical metrics such as R square and ANOVA, along with residual plot for validations. The analysis aim to provide a clear understanding of how those factors contribute to agricultural productivity, offering the practical implications for resource optimization. The interpretation of the multiple linear regressions result. So the table for the regressions coefficients table. Predictors, coefficients, standard error, t-value, and p-value, those are value presented in the regressions coefficients table. So the explanation of the part by the predictors. Intercept, a base crop yield of 227.79 is predicted when all over variable are 0. The next one predictor for the soil fertility, each unit increase in soil fertility increases the crop yield by 37.97 kg per hectare, holding other the factor constant. This is statistically significant at p less than 0.001. So the next predictor for the rainfall, the each additional of rainfall increasing the yield by 0.52 kg per hectare with a highly significant at p less than 0.001. The pesticide usages, the each unit increase in the pesticide usages improving the yield by 5.77 kg per hectare with p less than 0.0001. So the next one table for the ANOVA table, the source, degrees of freedom, sum of square, mean occurred, f value and p value all are presented in the ANOVA table for the multiple linear regressions. The f statistics of 2823.69 and p less than 0.0001 indicate that the regressions model is highly significant. The models explains a significant portion of the variation in crop yield r square is equal to 0.9946 with minimal residual error. So the interpretation of the residual graph, individual with soil fertility. The description of the graph, a random scatter around 0 indicates no validations of linearity or homogeneity assumptions. This suggests that the model correctly captures the relationship between soil fertility and crop yield. So the interpretation of the residual with soil fertility graph. Soil fertility has a concerned and significant impact on crop yield with no observable systematic error. So the next one for the residual with rainfall graph in multiple linear regressions. The descriptions of the graph, the residual plot shows no clear patterns, implying that the assumptions of independence is met. The interpretation of the residual with rainfall graph, the rainfall influences the crop yield as expected without introducing bias in the regressions model. So the next one graph for the residual with pesticide usages in multiple linear regressions. So the description of the graph, the residual are systematically distributed around 0, indicating that the pesticide usages does not introduce heterogeneity on or non-linearity into the model. So the interpretation of the graph, the pesticide usages has a linear and constant effect on crop yield. So the next one part of the result of multiple linear regression. The multiple linear regressions analysis provide a robust model with significant result for all predictors. The model achieved a high R square value, indicating that the majority of the variability in the dependent variable was explained by the independent variables. The each predictor soil fertility, rainfall and pesticide usages was statistically significant at p less than 0.0001, the demonstrating their critical influence on the dependent variable. The coefficients indicated positive contributors of each variable, quantifying their individual impact on the outcome. The residual diagnostic confirmed the validity of the model, with residual evenly distributed around the 0, supporting the assumptions of linearity, homogeneity and independence. The ANOVA result further validated the model's overall significance, making it a reliable tool for understanding and predicting the dependent variable. So the conclusion part of the multiple linear regressions. The multiple linear regression analysis highlights the effectiveness of using statistical method to understand complex relationship among variables. The finding confirmed that the soil fertility, rainfall and pesticide usages are significant predictor of the outcome, providing the actionable insights for practical applications. The validations of model assumptions ensure reliability and accuracy, making this analysis a strong foundation for decision making and further explanation. Those results understand the utility of multiple linear regressions as a vital tool in a research and real world problem solving across the various domains. If you any doubt on these sections, leave me the comments in the comment box. And if you like this video, click to the subscription button. Thank you for watching this video.